Ladies and gents, welcome back to another Engineers podcast. Today we're joined by Ravi Trivedi, who's a VP of Engineering at Tecton, and Mary Solbrick, Staff Engineer at Tecton. Tecton are a phenomenal business. They've built their business around accelerating data to be production and AR ready and trusted by some of the most respected engineering businesses around, such as Coinbase, Plaid, GoDaddy, and the list is endless. We've got quite an exciting episode today talking a little bit about how to build a really good developer UX on top of the business that they've built. Investing in platform teams compared to most startups, which I think is a really, really interesting topic. So I'm looking forward to digging into that one. Challenges building data intensive systems and building in house and building tools. Building in house is a topic that I've seen once or twice here on the podcast. And I love the notion behind this and really looking forward to exploring this a little bit further with Ravi and Mary. Enough of me. Ravi, will come to you first for an intro, then obviously come to you, Mary. So, first and foremost, thanks for joining the podcast. Ravi, take us away. Give us a bit of an intro into you.
All right, Elliot, thank you for the warm intro. So, my name's Ravi. I'm the VP of Engineering at Tecton. I've been at Tecton for close to 5.5 years at this point. I've been based in New York the entire time since before COVID. I like to say that I joined on day two of the company. There were just a couple other employees plus the founders. There were no customers. There was no revenue. The website was a picture of a mountain or something. So very, very early on. And so when I arrived, the project was build the first shippable version of the product for the customer that we will get at some point in the future. And that that was the starting point for Tecton. And at that time, it just so happened that a couple engineers that also were part of the early team were based in New York. So we always had a bi-coastal presence. And then COVID, of course, started after that. And we went remote and distributed, but we now have offices in New York and SF. And the company overall is just over 100 people at this point, roughly half of which is engineering. So it's been a fun ride.
Love that. Day tour. Now we're on to 8-9 monther. Mary, thanks for coming to join us. Do you want to give us a bit of an intro into you and your background?
Hi, I'm Mary. Elliot said, I joined Tecton about 8 months ago. I've been in software for about 10 years, though, 3 different companies. Before Tecton, I was at Apple working on the machine learning training platform there, so much more on the compute side. And then before that, I was at Tableau, which is specialized in a BI analytics tool for helping people see and understand their data. So it's kind of like a theme throughout there of trying that sort of emerged. Wasn't like my intention, but kind of emerged of like working on tools for data experts, whether that be analysts, data scientists, data engineers, and trying to think about how to make the tools that can make them successful. Before that, though, I actually didn't actually come in thinking I was going to go into software engineering. I went in thinking I'd go into academia, math, and physics. And that's what I went for school for. But then I sort of realized that wasn't really the right career for me. I like the subject, but not as a career. And I think that what I found in software engineering is there's just something really satisfying about knowing that you're building something that people are using. And like you get a bug report. It's annoying that there's a bug, but it's really exciting that someone is using your software and finding bugs. And so that was kind of a transition I made. I think it's kind of like I didn't really do a lot of software engineering when I was growing up, but my dad was a software engineer, and actually my grandmother was a software engineer coder at Los Alamos. So it was like, okay, so math didn't work out. Software engineer sounds like a good idea. So that's kind of how I got into that.
Love that. It's in the blood. Ravi, it probably only seems right and fair. Day tour. Give us a bit of an intro and almost the elevator pitch into Tecton. Who are Tecton? What are you building?
Yeah. So I guess I'll back up a little bit before Tecton. So Before Tecton, I worked at Google, and I was a staff software engineer working predominantly on platforms and infrastructure. I started as an SRE actually on Google Photos, which kind of happened as an accident, but it ended up being a very rewarding experience, and then moved on to the internal platforms team that became ubiquitous across the entire company. And so inadvertently, when I was at Google, I actually was working on search logging infrastructure, which was a very robust but different version of like the same problem that Tecton solves in a lot of ways, because the logging infrastructure ingested a bunch of user interaction data and used it to determine things like search ranking, experiments, and so on, which ultimately improved the user experience for Google. And when I was looking around for my next steps past Google, I came across Tecton and through a referral. And it turns out that the same problem really exists in a lot of different companies. And Uber was solving the same problem on their Michelangelo platform, and so that's where the founders of Tecton came from. And it just so happened that ML platforms are complicated and also very expensive to build, because you need a lot of really strong engineers to build them well. And there are only a small number of companies in the world that can afford to staff engineering teams to build an ML platform like that, right? Google, Uber, Facebook at the time, now Meta, Apple, for example, those are companies that can afford to do them. But what about the other 98% of companies? Uh, and so Tecton was a bit, so I'll jump into the Tecton pitch. Tecton was ahead of the curve on this problem. And they saw this as a problem that could be like useful for every company. And as more and more companies start putting machine learning applications into production, uh, the need for a consistent principled ML platform was necessary. So that's the genesis of Tecton. They went out, raised money from the best investors, and the company was born. Um, at its core, the problem that Tecton helps companies solve is putting ML and AI use cases into production. And the in production piece is very important. In a lot of cases, it means making predictions and decisions in real time based on data that in many cases is being updated in real time. And this the step from development into production, especially when you're even ignoring the data part of the problem, like it's a large software engineering, it's a distributed systems problem. But then when you throw data engineering into the mix, throw model versioning, model serving, like the problem just blows up in complexity. And so a lot of companies really get stalled when they have some use case that they've dreamed up or even maybe run some experiments on, but they can't put it into production reliably. And so this becomes a team operations at scale problem very quickly. So if you have one or two use cases, maybe you can cobble something together. But the minute you have three or four or five, suddenly you're staring down the road at a very complicated problem where you need a principled platform to build upon. So that was the gap that Tecton filled. And it really bridged the chasm between development, experimentation, model training to using models in production. And early on, this was dominated with predictive ML and predictive models, which today are considered old school machine learning in a way. And now it's been complemented with large language models and more broadly, just AI applications in production.
Love it. Solid intro. Solid intro. And I feel like we're going to dovetail quite nicely into, I love this line and I've just pulled it up. Best AI teams aren't blocked by data engineering. They're using Tecton to turn their data into smarter models and predictions. Yeah, I really wanted to demystify this. You've given us a great pitch into Tecton, but I'm going to pass the baton back to Mary, really to talk about some of the importance of data in model training and inference. So take us away on that, Mary.
Sure, yeah. I want to just actually start with, like, if you just think about inference, like I think that you really want to think about, like, these are models that we're trying to do something. The prediction one is a good one to start with, of like, okay, you're trying to decide, is someone going to commit fraud or not? You want to think about, like, you don't want this just determining, like, okay, this is Rob, and Rob is trying to buy socks. Okay, this is probably fraud. That's not enough information. It really is like, what is all of the information you can get to that model at serving time such that it can make that at that prediction? And it can actually be a very simple model if you've got enough data, right? It's like, what is their credit score? How long have they been a user? How expensive are these socks? And so it's the real challenge in those sorts of things is not how do you train the best model, is how do you get all of the data as quickly as you can to that model such that it can make a really fast decision. And when you get it like that, it's like, okay, yeah, the modeling part is kind of more solved right now. It's really about the data engineering and the data serving, getting the data that you want in the format you need to the model as quickly as possible. So, and that's sort of like, you can see like that also then expands to a lot of different problems. Prediction's a good one, but that's the same sort of thing you'd have in Gen AI is like, okay, you want to have some sort of AI element foundational model. You don't need to think about the training. It's about getting the information you need for that prompt, for that query to the model as quickly as possible. Well, how do you make that automatable, sustainable process? And then how do you make sure that you're training on exactly the same format? Because like that'd be really suck if like you have like one definition of like recent customer or something that you're using and serving, and then that's a different definition than that you're using for training. And so then it's like, not only is it like, is it the right data? How do you get the data to it? How do you make sure that it's all consistent? And you're using exactly the same definitions in production and serving that's updating real time that you're also then doing in training that's going to be at large scale training stuff.
Where are your typical challenges? Do you find, training models
Mm.
at that scale?
Mm. Um, it's sort of interesting is like, it's not coming from Apple. There was like one set of like at that scale, right? Uh, the scale may not be as important in some of the things that are going to get you a lot of value. Again, you might be able to do a prediction model on a huge amount of data or a small amount of data, but some of the challenges are going to be the same either place. Yes, you want to make sure that you're training really fast, so you're not spending a lot of money on training, and so you want to get the data to it quickly. But the more of the challenges is how do you make sure that it is really consistent and that you're not trying to, like, if you're training once a month or once a year, you're not trying to remember how did I set that up a year later. And I honestly think those are like the bigger challenges, and one of the places where Tecton really shines in terms of how do you make sure that you define once and get really consistent results everywhere.
Yeah, one thing I'll add to this is a lot of our customers, they sometimes have maybe one or two use cases in production, and they see the writing on the wall. They quickly start seeing where this is going, and it's not a place that they like. And it becomes quickly intractable in complexity. And so they sometimes approach Tecton to say, hey, this is, we want to get our third, fourth, fifth, 10th use case into production. We need a more robust system. And the interesting thing that we've seen is that some customers actually, like, they take an existing production use case and switch over the underlying data infrastructure to be backed by Tecton. So the model itself is the same. They're just replacing the data pipeline. And they notice the model performance increases because there's a more consistency between their training and serving environments. And so, the inconsistencies between those environments and the number of things that can be lost in translation between an experimental environment and a production environment actually just reduce the efficacy of their models.
Got you. Got you. The thing that I'm starting to learn and love about Tecton is simplification, and we're talking about this as if it's quite an easy thing to do. And something that I loved from our conversation first time around, Ravi, was you said putting ML applications into production is hard, and it touches nearly every single system design challenge or corner of system design challenge that you can think of. And I wanted to explore that further and go into that a little bit deeper and almost what you meant by that statement.
That it is very hard. Yeah, I think there's no sugarcoating it. The fun thing and also the hard thing about infrastructure for machine learning applications is that it touches almost every difficult software engineering problem. Like, it touches data engineering, it touches distributed systems, it touches like a lot of interesting versioning challenges. There's the need for an elegant developer toolkit. Um, even and any given part of the system is a really difficult engineering problem on its own. And so, anecdotally, when I talk to people who have like applied to Tecton on the website or something, and I talk to them about they often ask, like, I want to just solve some hard problems. Like, which teams have those? And my answer is always every single team. Like, there are no easy teams here. And so, from in broad strokes, uh, I'll walk through like three key pillars of the product, and there's plenty more to it. But feature engineering, batch compute, and real time. And so, feature engineering is there are kind of two really interesting axes to the problem. One, there's a developer experience axis. So you need to build tools that are friendly and usable to ML engineers. And ML engineers, even data scientists, are very opinionated, and they have their toolkits that they like, and oftentimes they're not they don't like to change those if they're working well. And so you need to meet them where they're at and build a toolkit that's familiar to them. At the same time, you need to build a set of elegant abstractions over fairly complicated infrastructure, as we've talked about before. And so you need to build something that has a nice abstraction layer over something that spans what they're running locally, but also what they're running in production. And you need to have a developer toolkit that is portable from the local environment to a production environment as well. And then there are a number of like developer workflows. Like once you'll be iterating on things in a experimental environment, and then suddenly move a use case to production, you'll have the same data available in a production context. And then at that point, a new lifecycle emerges where you're going to be iterating on the use case in production, and you also can't let your serving pipeline go down. And this introduces like this entire second axis of feature engineering, which is this like complicated end-to-end data problem, which is how do you manage pipelines that are spanning offline data, online data, and actually touching like distributed systems infrastructure. But it needs to be friendly enough that your ML engineer is able to reason about it. And so that's like one interesting UX problem that Mary's team spends a lot of time thinking about, or all their time thinking about. And then batch compute, on the other hand, is like, for a long time, we delegated to external compute engines. So we delegated to things like Spark, to data warehouses. And so all the lifting and the computation was done externally out of Tecton. And then we would have a number of different workflows that read data, transformed it, wrote it to different storage layers. And then over time, we actually built our own engine because we started realizing that relying on external engines has its downsides. It has a lot of integration complexity, and it becomes this huge orchestration problem because it's like basically there's this piece of infrastructure that's just looking to constantly do work. It's an orchestrator, and it's integrating with all these different mediums. In some cases, across different clouds, across different compute engines, at different cadences. That in itself is a hard problem. And then there's the real-time piece, and you're doing things like you're serving values in real time, sometimes at tens or hundreds of thousands of queries per second. You're doing real-time calculations as well. So it's not just serving a value to the end user over an HTTP API. You're doing calculations on the fly. In some cases, we actually have this Lambda-like real-time transformation layer where you can run arbitrary Python at every request. And that in itself at high scale becomes an interesting problem to offer an SLA or offer an HTTP API that has a reliable SLA along with it as well. There are many different layers here as well, but I'll stop there. But I've touched on three key pillars that are each uniquely complicated.
Those three key pillars alone, you touched on it earlier in the podcast, there's only a select few companies here, Uber, Google, who have really had the opportunity to explore this problem with the sheer scale, the complexity of the problem in itself, to be able to help other organizations. So I think it's really interesting to break down those three different pillars and understand some of those challenges inside of what you're likely to see. No easy team is what I deduce from that. Mary, want to come to you. Uh, Ravi was talking about the complicated workflows, and your team is really focused on building a really good UX. Talk to us about that difficult but rewarding experience of building a really seamless, easy to use UX.
Yeah. Yeah, reiterating, so my team, we own, if we think about Tecton as getting the data that you want in the format that you need when you need it, my team is focusing on that first portion of like, how do you express what is the data that you want? And then how do we turn that into the data that you need and format that you actually need to serve that? Data is sort of interesting in that like there's a lot of tools for defining data and expressing data, and you don't want to be designing from scratch. Like, you want something that looks familiar, and so you need to like go and say like, well, what is the standards? What are the things that people already know and are really comfortable with? And there's variety in that. So you also need to think of like, well, for data and ML engineers specifically, kind of what are the tools and how do you make sure that it feels familiar to them? But there's also restrictions on what you can do and what's going to make sense and what's going to be performant when we're thinking about these particular use cases. Specifically, like we need something that can stay fresh and can stay iterated, and something that isn't going to take 3 days to update every time you run it. And so that actually kind of does also add restrictions once you really understand end to end what's happening. And so then you want to make sure that you're giving something that feels familiar, but is also adding all of the sort of like right best practices sort of built in, so that it guides them to the right sort of mindset of, okay, I need to write this query like this. Um, and that's challenging. In part, it's like, okay, I need to make sure that I'm working with them and really understanding what is it that they need end to end. You kind of need to understand the whole flow so that you can make sure that it's performant, but also feels right. Uh, it's definitely rewarding because it's hard and it's interesting, and then gets into but I need to make sure that this is actually, I need to actually understand what are they doing end to end so that I know that it is performant and feels correct and expresses what they're trying to do. Yeah, I think the other thing is like these are also really smart people that we're working with, and the really technically deep. And so you can also really work with them and sort of understand like, okay, what is it you're trying to do, and get a lot of information from them to design something that works. Yeah.
Yeah, I think that's key. Like really understanding their day to day, their minds, and how they work and their workflow specifically to be able to build a really good experience for them, especially in dev tooling. I think that's key. Ravi, I want to speak to you about building this platform engineering culture in the business, and the sense that I get over the last 20 minutes, give or take, is everyone is a builder at heart. Built your own tools as an example, which we'll touch on, but talk to us a little bit about that mindset and why the idea was there behind building your own platform engineering culture really inside the business.
Yeah, there are many layers to the platform engineering concept and culture at Tecton. And a saying that we used to throw around at Google quite commonly was that it's turtles all the way down. Like it's just platforms on platforms on platforms on platforms and so on. And the same is kind of true here. And I think there's two variants of platform that we can talk about. One is external platform. So Tecton is the platform that other teams build upon. Uh, in many cases, our key customers are ML platform teams as an AI platform teams themselves, who then service use case teams. And then we also have internal platform teams as well. So I'll talk about external versus internal real quick. So for an external platform, like your reliability is key. That is the most important thing. And if you are something that it's not a point solution solving a very specific problem, like like a Slack plugin or something like that, it's something that your business, your product, your team needs readily available on a day-to-day basis, on a second-to-second basis, like reliability becomes very paramount above everything else, right? And so in some cases, especially like one of our big verticals is fintech and financial services. So if something like Tecton that is powering, let's say, fraud or some sort of KYC use case or something like that, if it goes down and the decisioning engine for whatever use case it is out of commission for even like a minute, that can amount to a huge sum of money and a great expense to the business. So reliability really is paramount, and it needs to be like the key principle that in everything that we build. And it takes a very long time to build trust in general, and it takes only a few seconds to lose a lot of trust with your customers. So um, that's why like Tecton is a platform, and we position it as a platform, which means you need to be extremely reliable. You need to give your like Mary was talking about, just how technical our users are. They are engineers, just like us, right? And you need to be able to give them a lot of visibility and control into what Tecton is doing in order for them to have confidence, as well as the ability to debug and mitigate things when something goes wrong. Because if you spend enough time building software, things will go wrong. It's not cross your fingers and hope that they don't. Things will go wrong, and so you need to plan for that. Internally, we've also invested in building a platform. So when you're a young startup, it's nice to say, okay, well, every team is very vertical. Each of them are just these different kind of SWAT teams that build different features and then move on to the next thing, and they don't really talk to other teams so they can stay focused. And that is, at some sizes and for some types of products, that's the right setup, even at larger sizes. For Tecton, I think we started as the problem statement, or the product we were building started quite simple. It was very much like a data pipeline that wrote to offline and online stores. So it read some data, did some transformations, wrote to an online and offline store. An online store might be something like DynamoDB, an offline store would be like S3. That quickly, the number of permutations of data flows quickly blew up in complexity. So we introduced streaming into the mix. So we weren't always reading from batch sources. We introduced new methods of ingestion. So you can connect to a Kafka topic or a Kinesis stream, or you can just shoot records at our HTTP API and let the system do the rest. It's a very clean integration pattern. We also started to support different types of data and had a lot of different operations in the background to make data serving more efficient. Because a lot of these use cases, you want to optimize for the read path, not the write path. And so there's often a lot of background work that goes into making the data available in the lowest latency possible at read time. So quickly, the number of data flows really just blew up in complexity. And also, when you're a small engineering team, you can say, hey, every engineer should know how everything works. And quickly, that methodology falls apart. So we invested fairly early in a platform team, and we're building it up this year. The key thing that we want to enable is we want people to be able to build on top of reusable building blocks to enable these different workflows. We also need to enable it in a way that is safe and stable. So we want to provide the guardrails for people to build things quickly and effectively without it being unsafe to do so. And the other key thing is that we don't want like a no mentality, right? Like it's easy to say like I have a culture of, or to regress into a culture of like, no, this won't work for X or Y reason, or no, this won't work for these reasons. But we really want like a yes mentality internally, but we want like a safe yes mentality. So you can, if there's a new use case we need to support, we should figure out a way how to do it safely without affecting the rest of our system and introducing a lot of tech debt. And then, we know the complexity will increase in the future. We're expanding to another cloud this year with Google Cloud. We have always increasing our security considerations because our customers are trusting us with sensitive data. And so we want to keep the ship moving with the appropriate guardrails in place. And so that's why we've been investing early in a platform team.
And I touched on it at the start of the podcast, especially building an internal, in your phrase, platform team. I think some of the cornerstones to that: reliability, reusability, consistency. I think it can really help teams speed up in the future, especially. So it's great to see that you're investing in that really early days. Mary, I want to come to you. We've we've touched on this a couple of times, but I think it would be great to share with the audience listening, in your opinion, what are some of the top challenges that you find building out data intensive applications? Because there's lots, and the data and the scale that we're talking about here with Tecton especially is vast. But it'd be really great to understand, in your opinion, what those are.
Yeah, I mean, I think that Ravi went through a lot of them really well already. But I think it's sort of interesting coming from more of the training platform into like really having to dig into these data systems and see the difference has been really a fun part of the transition to Tecton. And I kind of would describe it a little bit like if you're coming from back-end engineer, you have the idea of like a stateless server versus a stateful server. And you always want to have the stateless server, right? Of like, oh, I can just kill it. We can have 5 of them, it's fine. I'll just kill them, they'll be fine. And if I introduce a bug, I just need to roll back. And that's kind of like more like what's sort of the training side or like the serving side. But when you're dealing with data, it's actually kind of more like running a stateful server. Sort of one, if I introduce a bug, I may corrupt the data. And it's going to be worse than running a stateful server because it's not your data, it's the user's data. And so you've just corrupted their data and you have to figure out how to patch it, backport or whatever, or they may just have to quick rematerialize. And so you have to be a lot more careful of weird, subtle bugs. Like, did I change a data type? That may actually have much more impact than if you're doing something less data intensive. There's also security, like privacy and stuff like that. And then the kind of latency issues that you have to deal with when you have like lots of data become a lot bigger. So you have to think about not just like, how do I get this into the right locality? How do I get it in exactly the right format? What are the access patterns? And so that's part of why we have all this like online versus offline is those are very different access patterns. So how do you optimize something exactly for that really quick read versus how do you access something for these high scale training things in the format that they need? So it's actually been a really interesting transition. And I say, I think that Ravi talked about them, but it's been fun seeing like, just like, oh, why is it so complicated? And then you get into it and it's like, oh, it's complicated because we're dealing with data and we're dealing with customers' data. And so things become a lot more thorny.
The "it's complicated" tagline is everyone's least favorite response, I think. There are often, I think a lot of people out there who are considering something like Tecton or running into these issues, they hope for a poison, they hope for not a poison pill, sorry, a magic pill that fixes everything, right? They hope for, there are some cases where, you know, they have a hope that Tecton can dramatically just you can throw any volume of data at it, any use case of data, and it will always have the same performance characteristics. But the truth is, like a lot of our workloads that we're making possible for users, they're heavily dependent on what the user is doing with the product. So a lot of times, like Mary mentioned, latency, for example, we there's an expectation that's like, oh, we need to serve the data in XYZ P95 latency, and my answer is always, well, it depends. And it's like that meme where there's the guy who panics and hits the "it depends" button, which is the everyone's least favorite response from engineering. But in reality, is like these data intensive workloads, they're very nuanced in terms of like the performance characteristics and what's needed to make them successful. But we want to provide the tools to make that happen.
Also say like, even though it's complicated, it comes from like just a huge rich history of people who've thought about these same problems. So it's also like it's complicated, but you can go back and you can see like really principled ways of approaching these problems and pull from those. And it's sort of a fun thing about both here and Tableau is there's a lot of people who have like really rich history in terms of like where does this come from and how do we do this in a good, correct way and model it in a way that's going to be performant and principled.
Love that. Can we talk about building in house being one of your biggest competitors? I love this idea. I've seen a number of businesses utilize this really, really well. Ravi, it'd be great to hear your thoughts. It'd be great to hear your thoughts, Mary, on building in house and being able to harness and leverage some of the power that it can give you.
Well, let me start by saying I don't think anyone wants to build in-house. I think it's a means to an end in most cases. There might be some reasons for certain companies and use cases where it truly makes sense, but in general, I don't think anyone wants to build in-house if they can avoid it. There are a number of reasons. It's and even in a company like a lot of our customers are very sophisticated engineering companies. They have engineers who are capable of building very elegant principled platforms. Is that their core competency for whatever use case they want to enable? Probably not. Like I think they would, if they could treat it as a solved problem rather than staffing a 15-person ML platform team full of experienced engineers. I don't think they want to do that if they can avoid it. What we with build in house, what we see is there are a lot of cases that lead to it. Like a lot of it is in some cases inertia. Like we work with companies that are in some cases large enterprises, and there's a lot of inertia. They've built systems in the past, and here they are today. And there was when they started building these systems, there wasn't a platform like Tecton. And these are companies like that started in maybe the mid 2010s building these platforms, and they evolved into something new. In other cases, they might be like I mentioned in the beginning. Maybe a company will build or an ML team will build one or two use cases in production, and they'll say, why do I need a platform? This seems like a cool engineering problem to sink my teeth into. And then after running a use case or two in in production, they quickly realize what they've signed up for, and they don't like they don't like where it's going, and so they look for a more principled system. And so I think quickly, like they realize both the complexity, the time savings, the overall performance that they're going to get out of a system they build themselves versus a company that spends every breathing minute thinking about it. Um, and not to mention the cost, right? Engineers are a precious commodity, and so staffing these large teams is very costly. And so, if uh, a company is able to leverage something like Tecton to really scale their ML and AI applications in production, they're going to harness it. So build in house, like we see a lot of different varieties of this. There are some companies that uh, basically build. There are a few different paths. Sometimes companies build real-time applications in production, and then they go down the path of I need a platform. Other times they build batch use cases, and they might build a few batch use cases and say, this seems pretty tractable. These are things like, for example, forecasting, which are not very latency sensitive, and they run, let's say, workload once a day. And then they'll train models that are very effective for whatever use case, and then they'll suddenly run up against a brick wall once they try to put this into a production use case that requires real-time inference. There are other teams as well that, before they even start getting to these use cases in production, they have very large teams. And so they need a principled kind of fabric to work across for every team. And so the thing with all of these workloads is sharing and collaboration across teams becomes very important. And so every input into a model is a curated data signal. You don't want the same team computing the same signal twice if you can avoid it, because that actually is costing the company money. So they start looking for a platform that's both principled but also collaborative and shareable to share definitions and features across teams. And that's one of the key tenets of Tecton. Like, we allow people to stitch together features that are updated at different cadences, potentially owned by different people, into the same model. And so we generally just get to a point where we see a lot of companies getting to a point where they've tried to build these things in house, and they quickly realize, oh, this is a bigger undertaking than I thought. Often there's just one or two use cases that they really run up against a brick wall with, and then they approach Tecton. But other times they actually are looking at the multi-year path ahead, and they say, I want to partner with a strong platform to make this possible.
On the surface of things, I actually thought it was technology driven, but it seems as if commercially driven. It's got some real strong use cases for you, and it's almost better, easier, more collaborative, cost effective to actually use Tecton as a platform. Seemingly, case by case, I'm sure, but um, so building in house, interesting.
Yeah, there are, the engineer in me and myself and Mary loves the technology part of this, but at the end of the day, we're helping businesses solve problems that have a lot of value to the business. And if you're not delivering the value, then your product's not very useful. And you ultimately want to have like those use cases in mind. So we can build the coolest technology around, but if it doesn't map to a high value use case, and in our case, I mentioned a few examples, but like fintech, there's gaming use cases, recommendation systems, e-commerce, personalization. Like, we run the gamut, and some industries have a lot more use cases than others. But you need to really be like, have your eye on the prize with these use cases and enable those and really make them successful. The cool technology is just a means to enable that, and it's something that engineers get to have fun with.
Love it. Mary, what's your experience been like over the last 9 months coming into this environment?
Mm. Oh, it's been interesting. It's like yeah, it's a it's a broad question. Uh, it's definitely been interesting trying to move from a company where I knew a lot and had a lot of context for a lot of things, and we were building in house, but we were building in house at Apple, right? So that's sort of like a still a lot of different teams that you're serving, and coming here, and then it's needing to figure out how do you ramp up on something where you're new to the domain, you have to ramp up, and yet you're still going to come in sort of senior, and so you need to be able to figure out how to not have some of the confidence that you had before because you don't remember everything, but also still need to be able to say like, but I do still know principles. There's still principles that come from different places, and I know how to drive conversations, and so how to bring that in. So that's been sort of like the biggest transition for me, is just trying to figure out how to go from being somewhere where I knew everything to go to be somewhere where I'm new, but still remember that yes, there are things I know, and trying to identify what is it that you know and what you don't, and how to adjust to that. Um, yeah.
Love it.
Yeah.
Before we wrap up, I think it would be good to get some direction over the next 12 months on what you can share with us for people listening, where Tecton might be heading.
So I'm not sure how much we can really share, but one thing I will say is we just crossed our 1.0 milestone. So if you go to our website, look at the blog, we just shipped Tecton 1.0, and the company's 5+ years in at this point, and we just shipped 1.0. But really, the milestone, the functional milestone that we've reached, is like was worthy of 1.0. It was what we had envisioned us building for multiple years, and it includes the functionality set to enable like a large number of use cases. B, it includes a number of like key building blocks, like for example our own compute engine. It's called Rift, which was only built in the last year. And then it also has support for things like embeddings and certain Gen AI capabilities as well. And those are obviously a bit newer, but this is really like a big milestone for the product that we had envisioned building for the last few years. Going forward, this is not a popular answer, but it's going to be a lot of the same in some ways, because we want to stay focused, right? Like we don't want to spread ourselves too thin, and we want to solve a problem really, really well. And that is a way that we're going to deliver a lot of value to our customers. And so there will be a lot more of the same. There are still a number of use cases that we would like to support. There are a number of integrations that we would like to support. We're moving to a second cloud. We want to make ourselves available to more teams. And there will be some new stuff that I can't talk about, but we really want to refine the product, and we don't want to just like spread ourselves super thin. And so we want to make it really a platform that's super easy to get started with and super valuable for customers that have these really valuable use cases that they want to scale.
Love it. And lastly, growth in terms of hiring engineers, product people, salespeople. Talk to us about that for people listening that might be interested, who come from those backgrounds. I'm sure they can find you on your careers site, which will be tagged below, but high level, what might you be looking for of what you can share?
So we are hiring. Go to our website. There's a careers page. We have all of our recs listed there. We're hiring both for technical roles, engineers across the different domains that I had mentioned before. And we also are hiring for other roles like solution architects and the necessary roles to build an enterprise business, product managers as well. So yeah, please check out our website. Generally, what we look for is a combination of a lot of depth, but a lot of like, in a way, I think some people go the depth route and some people are more of just like hungry people with a lot of breadth, and they just love kind of getting stuff done and moving quickly. And we really like to build a team that's a combination of the two. So in some domains, we're looking for like deep experts, for example, on real-time serving. Like that's one of the teams where there's no easy problem to solve. It's all just interesting, difficult problems. But we're also looking for people that are just hungry and can move quickly and can experiment, because being able to rapidly experiment and meet new challenges, for example, we've been iterating a bunch on what we've been building for Gen AI. That requires a very different muscle than building a very stable piece of infrastructure that is like a well understood problem space that we just need to kind of build out. So we look for people who are very hungry, who can iterate quickly, and ideally have experience in the ML and data engineering domain, but it's not a hard requirement. And we're hiring basically across the US, and we have offices in New York and SF, and a growing cluster of people in Seattle, where Mary's based as well.
Yes, I'm definitely looking for more people in Seattle.
Love it. I want to say a massive thanks to you both. What a duo. I've loved learning a little bit more about Tecton. I was really looking forward to this one. Some of the businesses that you've worked with, businesses that, are publicly seen as doing some incredible things, and you're serving them 1.0s down. So I'm pleased to see where you're going to be, or I'm looking forward to see where you're going to be in the next 12, 24 months. And again, thank you both for coming to talk to us about Tecton and what you're building.
Yeah, thanks for having us.
Yeah, thank you, Elliot. It was fun.
Yeah, absolute pleasure. And for people listening, like Ravi said, career sites below, and this little ecosystem of 80,000 people on YouTube is made that goes round by likes, shares, subscribership, and all of that good stuff. And it's bye for now from us. Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Enginears is build a community to drive knowledge sharing and experiences. On Twitter, we can be found Enginears.io. It's no _. We've also got a website, which is engineers.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.